on what? You don't want me to start recording because your notes aren't ready? Like,
I thought you were changing the screen.
no, I just needed to get it started. Alright, so why will I teach you what?
I don't know what half of these
Oh, neither do I. No, I'll teach you everything you need to know to do our math. You might be right.
Did we? Oh yeah, we did because we did both.
No, but we didn't make it all the way through.
Didn't?
Yeah, we're continuing this. Because, like, we didn't get to this, right?
I don't know.
I really don't think we did. We started this slide. Like, we did this slide, right? Because this is the work we did. And we got these two values, and then I had you guys looking at these other quadratics. But we're going to keep practicing this, and we're going to do it all together using our graphing calculator to get really comfortable with utilizing the technology. So, why? Hey, 7th grade! I know it's not your fault that you're in the hallway, but it is your fault that you're as loud as you are. Please turn it down a tiny bit. Thank you. Alright, so, why?
As you get really loud.
Yeah, because I gotta be louder than them. Why do we use the quadratic formula, aside from there's such a catchy song to go with?
To figure out the two x-intercepts, right?
Yeah, now why, if we think tangibly, right, I'm trying to make you guys smarter than I am, if we think tangibly at why we can't use the method that we have been using up to this point, what did we talk about is different about quadratics like this? Because they're not fun numbers, right? So this was our quadratic formula of b, right? No. C, right? Was that b or c?
That was...
Well, check the pieces, right? Negative b plus or minus the square root of b squared minus 4ac. So that's got to be part c. Right, so this is what we did yesterday, because ac is what's right here.
Yeah.
And we know the denominator is 2a. So when we get to this, and this is what we're going to practice typing in our calculator. Now, some people with their own graphing calculators want to create formulas in them, and you can. I'm not going to teach you how to do that because there are people on YouTube that are way better at teaching you how to do that than I am. But I will teach you how to use your calculator in the way of like, well, this will make your life easier.
Should I like actually bring mine on like a day-to-day basis now?
Yeah, probably, at least for this chapter. Just so you're comfortable and have stuff saved in your calculator. So we know that there's a numerator and a denominator to the quadratic. I would advise that you open parentheses for the numerator. Now the first thing that we have there is the opposite of the b value. And we're going to try to type in one thing that we can copy and then like change values in to make our life easier. Yeah, so this is going to be our numerator inside of here, right? Now I will insert and say, well, actually I'm just going to go ahead and get rid of that parenthesis for now. So negative b. The negative button, as a reminder, is down here. It is not the minus button. Right, so we're going to type in negative b in this case was, yeah, we're going to use what we did yesterday. So b is 5, right? So we'll do negative 5. Now, actually, if we want to be able to use this, you could do a negative and then in parentheses put your b. But then you have to double check, is that going to apply to the rest of things? Is that going to mess anything up? And it shouldn't, because then we just add, right? Or subtract. So negative b, right? Opposite of b. Plus or minus, so we can't do plus or minus on here. So we just do plus to start. The square root, so second square for square root. Now here's one place where I am going to type this in different than what I did yesterday. I'm going to do that so that I can change the b value as I go through there. So negative b plus or minus the square root of b squared, then push your right button, minus 4. Now hold up, parenthesis Oh, now hold on. You want this to still be under the radical.
Yeah.
So notice on mine slipped out from the radical because I hit the right arrow too many times. So I go back here. Notice that that's different than this. Look at how this is different than this. It's not on the exponent. It's just under the radical. See the arrow inside of the cursor? So we want to be under there. So -4. Here's the trick. Put A and C in parentheses because we're going to then come back and change these values for other quadratics. Negative b plus or minus the square root b squared minus 4ac. Get out of your parentheses and close your numerator. Notice that on the graphing calculator, it changes the size of the parentheses to help you see what matches.
Oh.
And then what do we have to do?
Then over 2a.
Divide by, put your denominator in parentheses 2 just to be safe. 2 times the a value, which here is 1, which is really lame, but I'm going to do it anyways. I'm not trying to move fast. I'm trying to give you guys time to get comfortable with the calculator. I've been using graphing calculators longer than you've been alive. Quite literally.
No, that one before. The one before.
Parentheses.
Why is it so big?
Because it's big. Because there's a lot inside of
Because
it.
it has to hold
Oh,
the
I
square
didn't know.
root,
Okay,
and it
so
doesn't want to make
No,
the
so
numbers
you're still
smaller.
under the, you have to bump to the right. There you go. Now hit parentheses. So that's why I was trying to make you see the difference in the cursor. Notice how that's just a black box. In here, it's got the arrow. That's under the radical.
Okay.
Right? That's not under the radical.
Okay.
Then divide by 2a, and I put 2a. I put my a in parentheses because then I can go in and change it really easily. And I also put my denominator in parentheses to make sure that if I have an actual a value. Actually, no, I'm going to phrase this as a question. What's my issue if I do that instead of putting the denominator in parentheses?
Wouldn't it divide it before it multiplies?
It will divide and then multiply. Instead of multiplying the denominator value together and then dividing, which is what is appropriate in order of operations. So guys, what I'm telling you is this is wrong. Although here it will work because times 1 won't change anything. But this is not correct for how we would type this in. We need the denominator to have parentheses around it. Now remember that the insert button is your best friend. If I goof up an equation, second delete lets me insert things, and that's how I went and I inserted something in the middle of here. Second insert, and I can do whatever I want. It just adds and it pushes things. So whatever I type right now is being inserted until I hit the right arrow. And notice how I get my cursor box back. Sorry about the focus. I don't know what's going on. Actually, I do. It's because the camera's trying to focus on a screen that is confusing it. So we should have that now. Then hit enter. We go 1.14. Then second error. You broke. Oh, did you use minus instead of negative? Did you both get error?
I use negative.
Yeah,
Did you all get errors? Y'all did something wrong because these guys didn't get errors.
Of course, no.
So when you get error, click down and hit the go to. The go to will take you to the issue. You used a minus instead of a negative.
No.
Where?
Your closed parenthesis doesn't have an open parenthesis.
No.
You never opened your parenthesis for the numerator. So second insert, open a big, because that's big, you gotta have a big open. That parenthesis is around the negative, right? So this is parenthesis for the numerator,
At least I
and
didn't
that's
mess up
parenthesis for the
my
numerator.
Okay.
So now when you hit enter, it should work.
I got 1.14. Does that what you guys
You might
That's a
have to
minus,
plug
not a
this
negative. Replace it
calculator
with
and
that.
it's like,
You know what? I feel really dumb right now.
There's like no bad.
I just
hit
failed
that,
Spanish,
because it will
and
change
I'm
the
failing
minus
math
20.
now.
There we go. All good? All right. Now hit second enter.
Second.
Ah.
Copy paste.
Oh wow, isn't that
Right? Like I told you, your calculator is just a very simple computer. So that's your copy paste. And now I can go in.
I got the other one. Isn't it negative 6.14? So just
No,
change
wait.
this by.
Oh, don't hit enter again though. Sorry, I hit second enter and then I hit enter again. Now I can change all these pieces, right? So if I go to try to do D, B is 1, right? So everywhere that I have a B, I need to change that to a 1. 1. Those are my only B's, right?
How do you make it?
A is 3, and C is negative 14. So here, this is going to be an issue because I only have 2 spaces here. So negative 1. Then I have to hit insert to get my 4 in there. And change your other A over here for part D. That is up there on the screen.
Oh, so I should be doing that?
Yeah, just to practice changing these things and getting a different value. Now, actually, I jumped the gun on that. I should have up here done the minus.
I did the minus and it's negative 6 point.
Yeah, and get the other value that we got yesterday, right?
But then we
So
changed-
if this is for D, my B value is 1, my A value is 3, my C value is negative 14, my A value is 3. Here's my one answer.
Wait,
They're like
had
a
it done
million
again.
parentheses.
Second entry. That's why we don't want to type it in every time. We just want to change it. Then I come here and I do minus instead, and I get my other answer.
Great.
The insert button is very helpful. And then divided by 2, and then what?
Your 2A, right? So your A here is 3.
Okay.
Your A in part D.
So then it's 2.
So you should, so practice this, like test, do you get 2 and negative 2.33 repeating forever?
It's minus. Yes, I did. I know what I did wrong.
Did I do something wrong? Oh, I did something wrong.
Did you change all the values that you needed to change?
Decided to kill itself.
Like you changed your negative 7 to a negative 14, you changed your denominator value to 2 times 3.
I am not intelligent.
Calculador. How do I get 7?
Oh, that's where I
How did I even
Calculador.
get
Okay, good.
Negative B.
Got it.
Can I see your?
Let me go back.
I can't because it doesn't show the 2.
The 2 and then 3.
Times 3.
Pretty sure parentheses.
Oh.
It does it automatically.
Did you get 2? Okay, I got it. Yeah, I didn't change that number.
So you're confused. Your B here needs to change from a 5 to a 1. Our
Okay, so
B
then I go
is a
here,
1,
right?
because we're on part B.
I go here.
Our B is a 1.
And then I delete this. And I click 1.
Look at all my numbers.
But then it changes this
I have different numbers.
All right, are we mildly comfortable? Hey, you sound like you're arguing. Are we mildly comfortable?
Yeah, I'm fine.
So now the thing is, we always want to double check, is this a case that we need to use the quadratic for, or is it a case that we can solve another way? So, challenge for you. Go ahead and write down 9x squared minus 4 on your graph paper, please. And just set your calculator down for a minute because we don't need that at the moment. So the B has disappeared.
So what did you just do?
Sophia?
Wouldn't that mean that the b is 0? Because if you're multiplying 0 by x, then it would just be 0.
Yeah, so B is 0. So if we want to use the quadratic formula, all those B's are going to be 0. Absolutely. But do I need to is the question. Because as we saw from David's many complaints, there are a lot of parentheses and a lot of things to type into the calculator to make sure we do it right. And even if we think we did it right, we can still make a mistake. It's pretty highly probable. So one thing I will tell you, it would benefit you if you want to learn how to write in a code for the quadratic. And actually, there might be one in your calculator. I haven't checked the new calculators. They come with some softwares or some like formulas in it. But if you do a quick Google, you'll find out if it has a formula or how you can type in a formula for it. And then when you run the program, it would just say what's A, what's B, what's C, and it will do it for you. So when you build programs in the 83, and we're not doing it today because you guys don't have your own calculators right now also, but when you do that, you set up all the parameters of what it's going to ask for and what it's going to do. So you would type in literally negative B plus or minus the square root of B squared. You will type in using the letters on the calculator. And then you'll tell it to ask for A, B, and C, and it will just do it for you. But we don't need that here.
Yep, we don't need that.
I mean, it would give you 2 results then. That's all it would do.
Oh,
Are you serious? I just fixed you this morning.
B is 0, A is 1. So A wouldn't be -1, A would be 1. A would just be 1 and this is C.
I did ax squared plus bx plus c.
Oh,
But you need to do it in a program.
I know,
you need to
but I
type it
still
in
have
as a
it.
program.
I still know how to do the letters.
So if you go to, now that I've got you all curious,
Yeah.
if you look at your calculator,
I can go get my
I'm
own
not
when we get
program
more.
no, we might at the end of class. When you look at your calculator, this button says PRGM. PRGM.
Program?
Oh, haha.
So execute is run a program, right? New lets me create a new program.
Are you serious?
So yeah, we're not going to do this right now. I'll let you go grab your calculators in a minute. But that's how you do that. So second quick, get back here if you're in there and put your calculator down. You can even turn it off if you want because we don't need it to solve this problem. What we have,
Fortnite. How did you do that?
9x squared minus 4. So negative 36x squared. Hey guys, rejoin me please. But b is 0.
Okay, great. Negative
So
36x.
6 and negative 6.
Yeah. Oh, 6
Because they
is
cancel.
36.
Because they'll cancel out. Oh, so every problem like that, you just basically take the square root of
Yeah.
the absolute value, and then you make one positive and one negative.
Great.
Yeah.
So if it doesn't have a b value, then you know you can use diamond problem then.
Yeah.
Well, isn't that nice?
Because then we're always.
So wait, I have like
Right?
Great.
this.
Yeah,
Yeah.
sure, great.
Yes.
Hey David, I could use a little less of your attitude.
Oh, sorry.
I know you're just being like 8th grade sassy, but it doesn't make my job any more enjoyable. Wait a minute.
Wait.
So the 6's both directions. I probably have to split my 9x into 3's.
Yeah.
Yeah.
And then twos. A 2 and a negative 2.
So that factors out. Come on, smart boy. So it's almost like a perfect square, right? Because yesterday we looked at a over here and you guys realized, oh, that's x plus 3 times x plus 3. They're the same. We can write this as x plus 3 squared. This has a fancy pants name.
Oh boy.
This is called
Expression.
Different. Never mind.
Difference of
difference of
something.
squares.
Oh.
Yeah, sorry, that was because it's not really that there's no b value. It's that the two values created cancel each other. Because if I try to go back and think about that old school method of FOIL, right, the first, outer, inner, last,
So
my firsts are 9x squared. My outer, negative 6. My inner, positive 6x, like, negative 6x, positive 6x. And then I get negative 4. And the things I have green on are the only things that remain because the outer and the inner cancel out. So when you see something missing the b value, and both the a and the c are squares, you can just square root both of them. Exactly as one of you had said, is oh, we just take the square root of the a and the square root of the c. And then you have to write it out as one has plus and one has minus. So this then means, again, over teaching, our zeros here, I can write in a really easy manner. Because I can write, oh, my zeros are positive or negative, what?
0.
No. Remember what makes this 0 or what makes this 0?
X.
Yeah, the x being opposite of the constant divided by the coefficient. We talked about this 2 days ago.
That was 2
If
days ago.
that was also in the moment of turmoil where you guys are all like, no, what is going on? This, if we make this 0, right? What will make that 0? We add and then we divide. So here, because they're both the same, it's positive or negative 2/3. You don't have to know that yet, but when we get to the point that you do have to know it, you'll appreciate that we talked about it ahead of time. Questions on how we were able to recognize that using the diamond rectangle method?
So many realizations in 1 week of math.
Yeah. It's just like the power of overteaching.
Now, I don't know if you've been told this yet. Toby, go away.
Oh, I thought he was.
Toby, you've already heard this. No, it was just pausing for dramatic effect.
Oh, I thought.
I didn't know you. I know that.
Which means you don't have math class. Toby, go away!
Wait, has Toby already learned?
No, he already knows that there's no math tomorrow.
Oh, I
Seriously,
thought
he
you
keeps
meant he
wasting
already
it.
knows
He's
this.
still in the hallway. We're going to have a huge issue.
I think you were back.
I sure hope so. I think he just signed out, too. Oh, think about B. B's different.
So wait, what are we gonna do during math class?
Party. No, joking. No, joking.
What are we gonna do during math?
So, that is the thing. Mr. Hall is still teaching because he's not on the roof throwing things off. So, we're going to see how far we can get today. And then your guys' math class tomorrow is just like AO. Just do work. Yeah. Just try to. So, essentially, you lucked out because the pumpkin thing is happening. I would have class tomorrow. B would keep moving forward. But this will give you a day to like try to absorb. And you can sing the quadratic equation song.
Wait, so I don't have to.
You know what? I want you to throw Micah off the roof around.
Myself?
No. Our pumpkin's name is Micah.
What? That's really mean. That's my
It's
name.
not because of you. It's not because of you.
Name it Michael Wilson.
Yeah, it's Michael Wilson. Yeah, because he ditched our group.
We have a Micah Fenner now, too.
Oh boy.
Well,
Poor Micah.
his name is Micah.
For Micah, that's a rock. All right, look at B. Now, our C value has disappeared. Now, our C value has disappeared.
Wait. Oh, I thought you
I
were
don't
talking
know
about
why.
C. I'm like.
No, B, like B, we're doing B. So please
So
write down
wouldn't it
12x
still
squared
be 12x squared.
minus
12
16x.
at the top.
Now,
So then if it's 0, then it'd be times 0, then the thing would be 0.
right, so if we diamond this,
That's whack.
the A times the C is what we have.
0.
Oh, wait, that's A.
So it has 0 has to be one of the numbers then. And then negative 16, it's just negative 16 is 0.
No. Oh, yeah.
Because it's 0 plus something, it's just gonna be that number. That's weird. Yeah.
Everything times 0 is 0.
So if we think about the physicality of this quadratic, right? We have 12x squared. There's nothing here, so literally this space doesn't exist, which would also mean one of these spaces can't exist.
Oh, my God.
Oh.
Right, so if we make this 0, this is very Halloween-y, right? Ooh, maybe I should do this.
No.
Or write in black and make it Halloween-y. Orange and black. So wait, this,
Would be.
That'd be
Wait. X.
it has to multiply.
They both have to be X.
So one has to be 12, right? Or
one
both
has to be
be
6 and
6.
2. 6
One
and
has to be negative.
6 and 2.
Well, no.
What do you mean one has to be negative?
The X plus has to be negative. Because the two X's can't be negative.
Why do you need help remembering which one is A and different and which
Oh,
one
it
is
has to be
B?
4 to 6.
What do 12 and 16 have in common?
They're
4.
both
4.
So the one on the
What do
bottom,
this and this have in common?
they're both X's.
Take it out.
4x and 4x.
What are we doing here? What have we been doing all week long?
I
It's
really.
the F word, but not the bad one.
Federalism.
Federalism? No!
It is!
We've been factoring.
Oh.
Factor! Just factor! So guys,
We're gonna go to Mr. Allen and be like, factor!
You should. Please do that. Factorization. Seriously, guys, we are just factoring. So when you recognize that there's a common factor, whether it's a binomial or a trinomial, take out that common factor and make your life easier. So even if we had like the 3-term quadratic and they all had a common factor of 4, it wouldn't be 4x because then we'd have a constant. Take it out. Make your numbers smaller and easier to work with. Now, all we have left is 3x minus 4, right? So what does that make our zeros? Well, this is not hard. I'm sure you're thinking, oh crap, zeros. He's talking about that over teaching stuff again. Yeah. If I know that these two things multiplied make a 0, what would make this 0? What would make 4x 0? If x was 0. What would make this 0? Opposite of the constant divided by the coefficient. You will, like that will become just natural. It's okay that it's not right now. You don't have to be able to find the zeros yet. But when you get there, then it'll be easy. So when we have something missing the c value, one of our zeros is for sure 0. And there's a really cool reason why.
Wait, we're missing this because it's
what does the c value do to an equation? Any equation, actually. What does the constant value do to any equation?
It makes its y-intercept back.
Wait.
Yeah.
What?
The constant is the y-intercept.
So if 12 is the a value, 16 is the b value, we don't have a c value.
You are correct.
What?
What does the c value normally do in any equation?
It's the thing that's multiplied by negative 4a.
Y-intercept?
Yeah, and it's the y-intercept because it shifts
So this doesn't.
vertically, right?
So it's a vertical line.
It's a horizontal line. No, it's a vertical line.
Yeah, it's a
It
vertical
never
line.
passes through y.
It's a vertical.
And then the x-intercept is 4 and 3.
Check it. This is green. Your parent function, if I turn everything else off, your parent function, x squared.
Yeah.
12x squared, the a value, start to try to internalize this. You don't have to master this yet, but start to try to internalize it, is intensity, right? It's an intensifier because it is making the output value 12 times as much as it would be. So when I do 1 and I square it, 1 squared here should be 1, right? On the parent function, 1 squared should be 1. Like I'm dragging a point. But 1 squared should be 1. Actually, let's do this. Y equals, no, x equals 1. If I look at x equals 1, right? 1. But if I go to the 12x squared, you got to make the sound effects. Of course it's 12, because it's 12 times the normal x squared. So what your a does is intensify, right? If it's bigger than 1, it pulls it towards the y-axis. If it's less than 1, let's say it was 1/2, it pulls it away from the y-axis. So if we just had 12x squared, it would just tighten up the parabola. And if we just had x squared minus 16x,
Wait,
What the heck?
what just happened?
sorry, the vertical line was still there. X squared minus 16x.
Oh.
What?
It's because it has
Wait, can you just go back up?
I understand.
I want to see the line again.
Why?
Okay, so because there's no c value, you know that one of the x's is going to go to the origin, and then because there's a 16x, that means that the point is 16. Yeah, and then so right in the middle, that would be 8.
So if we had no a and you only had the bx,
So
This means that factored, right? This factored would be x times x minus 16, which makes positive 16 your 0. So I love to have x squared minus 16x, right? If that's what we had. And we factor out the common x between them.
Okay.
And we make this 0. There are two options. If x is 0, this will become 0.
Right.
Or if x is positive 16, this will become 0.
Right.
That's how we know where the parabola will cross the axis, the 0 point
And
and
then
the
the
16 point.
difference in between is
Okay.
when the
vertex.
vertexes.
And then
You
8
yeah.
squared, 64,
Yeah.
but minus
Yeah.
16 times 8,
Whoa.
which is why we're so far down there. But then, if we have the entire,
Oh, it's gonna be.
now that x squared, the positive value of that function, has more power, right? It's not just x squared, it's 12x squared. So we get a whole lot higher because that 12x squared,
It's a very.
but that also impacts my zeros.
Yeah.
But what I was trying to get you to see when you just recognize that there is no
Can you
C
take the other
value,
ones off so we can just see the 12x? Yeah, that makes it better.
so that compared.
Wow.
Now, if you really want to have your mind blown, so A, we said, is the intensifier,
Whoa.
right? If it's negative, it flips it.
Okay, great.
But if A is 1,
Yeah.
C, this is why I love Desmos, except it won't let me get to 1. Doesn't really matter.
Oh, well, 1.1 is closer.
Oh, well, he did.
I agree. C,
It's a line close enough.
C, vertical shift,
Yeah.
right? That's all. If I only have C, not B. But then, somebody's got to mess it up. B, what do you think will happen when I slide my slider for B?
It'll just
You ready to blow your mind?
no.
No way.
It's going in the shape of. Oh.
What do you think, David?
It's going the opposite parabola that it is. Right?
Is it?
Yeah, it is.
Anti-ooh.
Oh my god.
This B, if the only thing that changes, and if I make this 1 because A needs to be 1, if the only thing that changes is your B value, your origin will be a 0, and your vertex,
Wait, wasn't the origin normally 0?
yeah, like on the parent function too, but my B will travel on that parabola.
Oh, okay. I think I kind of get this, but this is like.
I don't think I get this.
It looks like it's a visual thing. It looks like it gets.
So here's the only reason I'm showing you that now.
Why?
Most people ask, well, what's the easy way to know what this does? B, there is not an easy way to know what it does, but all I need you to know right now is it shifts in a parabolic fashion. But B is actually the result of 2 other things. Actually, it's the result of 4 other things.
It's the A times the C, right?
Because the B is the value that we got from foiling. Right? Our B value comes from 4 pieces. Comes from this coefficient and this constant, and this constant and this coefficient. So since your B is the result of so much other stuff going on, there's no easy way to say like, oh yeah, B is 8, it does, or sorry, that's not B. B is negative 10, it does blah. No, there's no easy way to say that.
I have a feeling Monday is gonna be a
Oh my
special.
God. Wait,
Because there's a pop quiz.
What?
I feel like all the.
Well, because we're learning about this and it's Monday.
Wait, you understand this. You understand this.
I can't.
It's cool, like swirly.
It's
swirly.
cool, but I don't. This is over.
Well, duh, yeah, well, duh.
A little bit.
A little bit.
We'll
Like,
learn it like in the spring, probably. It'll have to be so. But that's like.
will we use that
I'm trying to give you a moment to just come back from the cliff.
I don't know if my mind is blown or turned to mush.
Here's one of the issues with teaching your class. And I love it, but for most of your math career, you've probably showed up to math class, been told, here's what we're doing, and you're like, yep, got it, good, move on.
Yes.
Nope. That's this class.
You have now come to the point where you should have been for years and years, but somebody forgot to, hey, move on up. Where you've come to math class and I've said, here's something you don't know. Here's a cool thing I'm going to teach you. And you didn't. Oh yeah, here, good, fine, let's move on. And that's good. The fact that you're like, I don't get this, that's good. That means that you've now come to the point of the productive struggle. And that is seriously a term I want you to put in your brain. Productive struggle. The fact that you don't totally grasp what we're doing right now, you haven't mastered it, which is good. You shouldn't master everything as soon as it's put in front of you. That would be boring.
Last year we were still doing y equals mx.
And then you took a summer class.
We were still working with linear equations.
Oh yeah.
And then you look at this and I'm just like,
And now we're here
I'm hoping some of my friends are in math 8, and I'm like, this was last year.
Now wait. I love that you just said that. Look at D. What are we missing in D? No? An A value. Which, if we're missing an A value, it's a line. What's your 0 of that line? Well, whatever ends, it's your y-intercept, or no, it's your x-intercept. But that doesn't even matter, because it's not a quadratic. Right? We don't talk about zeros.
Do you guys understand what he's saying?
There's the one non-quadratic for the rest of the year.
I just need to
Alright.
remember, in the
What
equation.
are you doing packing up?
Oh, well, I mean, I ran out of paper, on the paper.
Dunder Mifflin's right here.
I ran out
All your paper needs.
I ran
All
out
your
of
paper.
space on the paper.
Sounds weak to me.
What about the back of the paper?
Alright,
Yes,
so
I used both sides.
now, I like you guys, and we're running out of class time. So CPM would say, use the diamond method to factor da 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 da. And I'm going to skip over all the Charlie Brown, wah, 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 wah. What do you notice about 4, 10, and 6?
They can all be factored by 2.
They can all be factored by 2. So the first thing I'm going to do here is factor by 2.
Oh, I should write this.
Now, if we go to think through this, I don't have options for how I break up my x squared. It's just 2x and x. Right? If I worked with the 4x, I have options. It might be 4x and x, or it might be 2x and 2x. But now that I've factored out that 2, it's going to make things a lot more convenient for me. Negative 3 only has one option, a negative 3 and a 1. So we are left with 2 options. I can either have negative 3 and a 1, or switch those places. If this can factor nicely. Does this, we're checking, does this make negative 5? Outer, inner, no. So, we can then check positive 1, negative 3.
Does that make a 5?
Yes.
Oh my gosh.
So that's how it is?
And then, yeah, so this works. So we can go ahead and not write those in red. I guess we could do this. Which means our zeros. Sorry, that Z looks kind of weird. Is x equals 3 is the easy one. Or negative 1/2. And here's the sweet thing. This doesn't impact our zeros. Because if we have 0 inside of here, 2 times a 0 doesn't matter.
Wait, how did you get that?
How did I get what? Zeros?
Yeah.
Set each of these equal to 0. So x minus 3 equal to 0 would have to be positive 3.
Yeah. And then
2x plus 1 equal to 0, I would
Okay,
subtract 1, divide by 2.
I'm just
But again, you don't have to be able to find the zeros yet. You don't have to know all that. The last thing we're going to do today, which will be a probably challenge for you, is what if we have 3x squared minus 5x minus 2 in the area model.
Oh
Then we
boy.
walk out the door.
Isn't it a polynomial? Because
Wait, you
It's
learned?
it's more than a polynomial because there's another.
You're learning it as an 8th grader.
I know, but like, say, like, hold up.
Yeah, my brother.
okay, wait. I just want to say the board over there. They're adding like negatives and stuff.
We can solve this.
Well, that's like this is dirty math. This
Oh,
is
that Dr. Gupta did while he was here, and he didn't realize I'd already taught that, so it was kind of funny.
It's like
My students were being very polite, and they were waiting. But
it's
Are you
like
serious?
so nice. And then we have this.
yeah. You know what being an adult is like? Take the feeling that you have right
Probably
now.
this.
No, take the feeling that you have right now. Like,
Yeah.
being an adult is like solving quadratic equations. And when you're an
I know,
adult,
why?
you're like, man, college or high school or whatever you think back to, you're like, that was so easy. It was so fun. It was,
Oh
just
my-
go back there.
I
and
know
just-
why.
Because in
have a
school,
care about
you're like, I have taxes.
And then
My
in the
parents
fall-
are
and then in the
just
fall
like,
you're like, I have daycare.
wait, talk to me.
If this is x minus 2,
I mean, you just do the
Why
same
do you
thing
learn how to do your
except more.
Run.
Tax evasion.
So, hey, we can solve this. And it's not even that bad. If we have 3x squared, this has to be 3x, the other one that we're solving. And if this is negative 2, this would seem that this would have to be positive 1. And then let's check, does that give me negative 5? Well, outer plus 1, inner negative 6. Ooh, that works. So 3x plus 1. Now this is like a challenge, right? This is like a puzzle problem. And
Oh,
we're-
because in the thing, 3x plus 1 times x minus 2 should equal 3x.
So we could continue to do exactly what we just did and figure out what other factors will make this trinomial true. And then we can find the trinomial here and the trinomial here and put all the like terms together. But we're actually out of time for once ever.
Wow.
So tomorrow, just ask your 8th grade teachers where you're supposed to go during your math time. It'll probably be the library.
Go to Mr. Hall's class and just watch.
Or actually,
Eight kids.
we might, well, I mean, you can use that time for homework, but I was going to say we might be able to offer up, like, if you guys want to come help with something. But
I kind of want to use that time for
Honest walk
if I
around
have to
the
wait,
kids.
help
Yeah.
like with what?
with the pumpkin stuff or help manage kids outside or whatever.
If I'm done with my homework, I might do that.
Let me chat with the team. Oh yeah, give me the calculators, please.
If I
Let's go ahead and make a deal.
What?
So I'm trying to make my life easier this year. I'm trying to get smarter. These, assuming Leanne always brings this, and if you don't,
I'll
we'll get
start
another one out of the
bringing
drawer. But these, is that yours or mine?
That's yours.
You just
And
put
I
it on
feel
upside
like put it
down.
on.
You're okay.
Yep.
You put it on upside down, so it got stuck. I will leave these
I will start bringing
Yeah.
them if we're actually going to use them.
right here, and my 7th graders probably will not realize that anything has changed, and I will trust that, you know, this is about $500 worth of stuff right here.
boy.
But
Oh my god.
grab it when you need it, even if, like, it's not class. If you're AO or extensions or whatever, these are here for you guys, but please make sure they come back. Okay? Please make sure they come back. Hey, and you can't take them home. Yo, actually, let me change that real quick. If you need to take one of those home, talk with me. I'll probably just email your parent and say, hey, they're taking this home. Have a good day, Sophia.